I don't have any fancy computer programs or unintelligible equations or things like that, which are the trademarks of seminars these days. I'm going to give present some of my reflections, sort of storytelling, if you like. So that's what I'm trying to do. And as it is shown here, it's more than 40 years I have in this business. When it was, even before this activity was known, not known by the name agroforestry, I was involved in that. So this has been my bread and butter, and I have been with this all these years. I don't know how old agriculture is. Some people say it is 10,000 years old or whatever it is. But I would say modern agriculture started about maybe 250 years ago. A lot of people say that the invention of the hoe by Jethro Tull in England by about 1750, that was the beginning of the modern agriculture, when this craze for line planting of species, crops or trees or whatever, that started with the invention of the hoe. And in mid 1800s, the plant nutrient, just as von Liebig and others invented came up with the plant nutrients, essential nutrients, and all that. And people say that agricultural research, as we know it today, started by about 1850, around the same time, with the beginning of that activity in Rothamsted Experiment Station in England. And by early 1900s, fertilizers, the Haber process and Ostwald process and all those things came into existence or came to be known. And then the 1960s on for 3 decades, we saw the impact of the high yielding varieties and the green revolution and all that. And so all these technological innovations in agriculture for the past 250 years or so can be presented like something like this. And there's also, you can see the world population has been going up along the gradient and increasing consistently over these years. So this is a shot of the Rothamsted famous broadback fields, where I had the privilege of making some field measurements as a postdoctoral fellow in the early 1970s. So green revolution is said to be, or many people call that as the most comprehensive use of science and scientific procedures in support of agriculture in the past few decades, from 1960s onwards. So globally, it has contributed to increase in grain production threefold. Area under cultivation increased only about 10% during this period, but grain yield increased by almost threefold. The average grain yields went up from about 1 ton per hectare to 2.85 tons per hectare during this period until about 2000. So why this came into existence at that time, what was the background at that time is that the post-World War era, with the invention of the fertilizers and the commercial companies taking over agriculture, and agriculture becoming highly mechanized and industrialized in the Western countries, the use of chemicals, fertilizers, and other agrochemicals also was very much a part of that activity. And when the newly independent states of Africa and Asia, they got independence in the 1950s, 1960s, and all that, and there was huge increase in population, and the leaders of those countries were looking for ways to find ways to feed these teeming millions of people, and as in everything else, they looked up to the West for guidance, and they were given the advice, rightly or wrongly, to intensify agriculture, as they have done successfully in the Western world. And one of the essential aspects of that was some plant physiologists and agronomists and others joined together and came up with the idea of high yielding varieties of cereal crops, rice and maize and wheat and all that. So all these things contributed to the Green Revolution, and along with that, the high intensity use of chemicals, fertilizers and other chemicals, that was a part of the whole package. So this was a great thing that, that happened. Large scale hunger and malnutrition could be avoided because of the Green Revolution. Norman Borlaug, I have heard him talking with this slide on many occasions. He articulated that had we been at the technology, bullock cart technology, as some people call it, in, as they had it in 1950s and 1960s, had we been in that level of technology, we would have needed 1.1 billion hectares of land more to produce the 2,000 million tons of food grains in year 2000. So this Green Revolution has helped enormously in enhancing food production in many parts of the world, especially in the tropical world. That's it. And if we had not done that, we would have lost another 1 billion hectares of land, mostly forest lands. Some people call it the chemical agriculture. On its face value, the use of high rates of fertilizers and chemicals provides a compelling reason or compelling evidence to support their continued use. But there is another hidden thing that people don't realize, that is the costly side effects. They become apparent only in the long run. And if you can take an analogy with the food quality and human health, we all know that poor quality food causes obesity and other serious health issues. Similarly, people argue that excessive use of chemicals causes serious health and sustainability issues for agriculture also. That means soil health. Franklin D. Roosevelt, the president who was the president for most of the time of the Great Depression in the US, he very rightly said, a nation that destroys its soil destroys itself. So has science helped? Yes, indeed. Science has helped in augmenting food production through better seeds, more fertilizers and chemicals, adequate irrigation, improved implements, machinery, better infrastructure and marketing, enabling policies. So large-scale hunger and malnutrition has been averted in many parts of the world thanks to the Green Revolution. So science has indeed helped. However, there have been some costly side effects also, which became evident as we moved on. Eroding soils and declining soil fertility, advancing deserts, and deteriorating environment, diminishing biodiversity, you name it, increasing disease incidence, wrecking the climate, and widening the rich-poor divide, and all sorts of what some people call the malady. So the problem with the modern agriculture is that industrialized farming looks good because it measures its own success very narrowly and ignores the costly side effects. I know I'm going too much, I'm still in the background. I should also give a little bit of reference to the situations happening in forestry sector, especially in the tropical forest society. I think John Sachs says beautiful poem that explains the situation of tropical forestry. 6 blind men going and trying to describe an elephant. None of them has seen the elephant. They would go and touch and feel different parts of the big animal and come back in the evening and stir and quarrel and haggle about what an elephant is or should be or ought to be and all that. And finally, no conclusion. So that is exactly, I'm not exactly, but that's my thinking about what's happening in forestry, particularly tropical forestry. So if you look into the developments in tropical forestry also during the same time period that I mentioned for the agricultural sector, that is soon after the colonialization of many of the countries in Africa and Asia, 1960s, that's the starting point for many development indices. So exploitation of the natural resource was the main theme. That continues to be so even today. But the main scientific activity, science-motivated activity in tropical forestry also came with the establishment of plantations as in the Western world. And that continues to be the major activity even today. And although only about 7% or 8% of the total forest area is under plantation forestry, plantations provide more than 50% of the timber needs of the world. So it's a great activity. But by about 1970s, some social inputs started to flow into forestry. And because a lot of people rightly said that forests are such a vast resources, and the management of forests should not be left to a few people who are trained in forestry. It should be left to the decision. People at large should be involved in decision making and policy making in managing forest lands. So the social input came into forestry operations, forestry management around 1970s. And as a consequence of that, so many terms with the forestry ending, agroforestry, social forestry, community forestry, recreational forestry, you name it. Lots of things came into prominence, and some of them have fizzled out. Many of them were poorly defined. There were lots of overlaps in those activities. The resources that were available, very limited though, they were distributed among these various activities. And by about 1990s, the environmental issues became a major issue in the world arena. So climate change and all those things became very, very important by about 1990, 2000. Some other activities also came up, like non-timber forest products, timber certification and all those things. And as well, I haven't heard any major activity in tropical forestries after the REDD, after the REDD, REDD plus, REDD plus plus, and all those things came into about 10 years ago. I don't know, correct me or educate me, please, if what is the most common compelling rallying theme in tropical forestry in the past 10 years? I haven't seen anything. So this is the situation as far as the forestry is concerned. So we have looked at the developments in agriculture and in forestry. I'm coming to agroforestry. So agroforestry, I would say modern agroforestry, because agroforestry is nothing new. It has been there for ever since agriculture began. So it arose, the activity arose in the tropics in the 1970s and 1980s as an approach to addressing the pressing land management problems such as deforestation, land degradation, shortage of food, fodder, fuel, wood, and all those things. So that is how agroforestry came in, the initiative in agroforestry started. And I happened to be there at the first meeting that decided to initiate a global activity in agroforestry. And so I was there at that time in June 1977 at the meeting that was convened in the Royal Tropical Institute in Amsterdam. Why me? How did I end up there? Well, before that, I had a life also. I was doing things like I was attached to a tree crops institution in India, my native India, southwestern part of India. And there, the main emphasis, there also line planting was the rule. Everything modern in agriculture or forestry should all be always planted in line. Okay, so line planting was the main thing. So we had coconut plantations and other tree crop plantations of this type. So people have always been traditionally interplanting some other species underneath the coconut or in between coconuts. So that's nothing new. But researchers never paid any attention to those things. They used to ignore them. Oh, that's all, poor farmers' activities. So what we thought that, okay, this is a pure stand of coconut monoculture. It's a lot of light coming into that plantation floor, which is not utilized in a monoculture stand of coconuts. And the same thing with many other species also. And the soil resources are also not being fully utilized by those single stands of monoculture stands of those trees. So we did some things, copied some things from farmers, learned some of their tricks, and we made crop combinations, what we call multi-strata crop combinations like this one, with a variety of different species mixed together with the so-called main crop of coconuts. And that, and I had this grace of writing and publishing some things that I work on. So some people caught that caught the attention of some people who are convening this meeting, and at that time I happened to be in Germany, and they invited me to that meeting and on the steering committee that which would eventually become a steering committee for the establishment of an international activity called the ICRA, they call it, International Center at that time Council for Research in Agroforestry. And subsequently, they established a center in Nairobi, and eventually it became one of the international agricultural research centers of the CGIAR. By the way, I'm very happy that Dr. Pedro Sanchez, who was the leader of ICRAF in Nairobi for 10 years, is here. The activity of agroforestry became very prominent during the 1980s and 1990s. And the essential aspect of agroforestry is that, so bridging the ecology divide in fragile ecosystems by growing trees purposefully, growing trees and crops and sometimes animals in interacting combinations for multiple products and services. So this was the underlying theme of the whole thing. And by this, we thought of accomplishing the difficult task of transforming traditional practices into science-based technologies to provide answers to land management problems under resource-poor conditions. This is how the whole activity started, and different estimates are available on the area that is under agroforestry or agroforestry type of activities, and 1.6 billion hectares of land globally, not only in the tropics. That's a figure that is commonly used. So this is where how the whole thing started, agroforestry. I don't want to go into showing the different pictures of agroforestry and all that, but I want to give you some idea of what we are talking about in terms of this tropical agroforestry. There are different types of products that come out of these systems, which you cannot get from any single species system anywhere in the world, and they all contribute to some extent to the nutritional security of people, and also to, in some cases to the economic cash security as well. Then a talk about agroforestry cannot go without mentioning some of the wonderful tree species that people have been using for millennia in their farmlands. This wonderful tree, some of you may not know, so I'm showing it here, the Phyderbia albida, which has a remarkable phenology that it does not have any leaves during the rainy season. So if you travel around West Africa, which is very common in West Africa, the Sahelian area, and if you travel around West Africa in the rainy season, you find this tree standing with just branches and stems and no leaves, and you think that's a dead tree. But the rainy season is usually very short, 3 months or so. Once the rainy season ends and the crop is ready to be harvested, the leaves come back. During the long dry season of 8-9 months, that tree is the only tree that has got some leaves on that, and it's a very prominent thing on the landscape in the whole of that part of the world. So this is a remarkable tree, and lots of work have been done around about this tree, and also about trying to understand the science behind its soil improvement qualities and stuff like that. Then there are also many other indigenous trees with which people have connections over millennia. See this tree, for example, the Vitellaria paradoxa, the shea butter tree, that's getting into popularity now, and some people predict that could be the equivalent of the rubber tree in the future, because rubber tree also started like that. There is no other species, agricultural or forestry species, that the average commercial production of which has gone up by 150% within a span of 1 century or so, like the rubber tree, because they invented that, and they large scale multiplied that and introduced in large scale in Southeast Asia, and the rest is history. So some of these species that people have traditionally been using, and they always use this sort of trees along with crops. You know, they interplant the stand of those trees with crops. This is a traditional practice. So, and there's a lot of lots of social and cultural activities associated with this sort of land use system. This is not pure science that we are talking about. This is the interface between science and practice, science and social. I mean, social science is also a science, but not the high quality, high tech science that we always talk about in agriculture. So there is a lot of social involvement in managing these systems. Then animals. Cattle are an essential component of the farming systems, and it's a source of, the screen is not shown fully here, but it's the source of wealth in many traditional societies, and wealth is counted in terms of the number of herds they own. So that's a very traditional practice. And animals are vegetarians. They eat only leaves. And most of, I mean, I'm talking about this sort of animals. So most of the leaves that these animals eat, and that's the animals are sustained, those leaves come from trees and shrubs. So you can see the importance of these species in the livelihood and farming systems of those areas. And of course, this practice has been improved now to commercial, what we call silvo-pastoral systems. And this is a shot of beef cattle being grown under the silvo-pastoral systems in the eucalyptus hybrids. They feed on the Brachiaria brisanta, the fodder grass. And so commercial systems have been developed like this, particularly in South America. Brazil is a leader in this sort of activity. So this activity of agroforestry was not limited to the tropical situations only. It was also spread into the temperate regions. I have with us today Dr. Felix Herzog, who is the head of the research division of, what's your company's name? Agroscope, the federal ministry, one of the federal departments of Switzerland. And he has arrived yesterday for a short stay with us as a visiting scientist. He is very much involved in the agroforestry in Europe, which is catching up in a big way lately. So in the temperate zone also, including North America and including US and Canada, that is North America, agroforestry has been going on, but not up to, in my thinking, it could have been better, but we had activities in agroforestry in North America also. There's an association for temperate agroforestry and several activities. There's a small unit of agroforestry in the USDA Forest Service. But even before this agroforestry came into scene, some people, far-sighted people have talked about this thing. For example, J. Russell Smith in 1929 published this book called Tree Crops, A Permanent Agriculture, which was reprinted in 1950. And he said, an agricultural economy based almost entirely upon annual crops, such as corn and wheat, is wasteful, destructive of soil fertility, and illogical. That's what he said at that time. So some people have been thinking along these lines for quite some time in the temperate zone also. So after lots of discussion, deliberations, and haggling, the Association for Temperate Agroforestry has settled into classifying agroforestry practices in North America into 5 categories: alley cropping, forest farming, riparian buffers, silvopasture, and windbreaks. Different types of activities have been going on in all these different types of practices, particularly in the alley cropping, riparian buffer, and windbreaks. Silvopasture research also is going on, but that's also, as I said, not only in North America, but also in South America, Latin America. There are silver pastoral practices in Asia and Europe, or Asia and Africa also, but that's a very different type of silver pastoral, not the sort of organized line-planted silver pastoral systems. So the scientific foundation of all these mixed species systems can be traced to one of the hypotheses is the niche complementarity, where a larger array of species in a system leads to a broader spectrum of resource utilization and more efficient use and sharing of resources, making the system more productive. This is one of the fundamental concepts of that, and coming to my own involvement in these things, there are several ecosystem services or several categories of ecosystem service that can be recognized. Four of them are listed here. And my work has been concentrated mostly because of my background and all that, mostly soil productivity issues and climate change mitigation and adaptation. I would say out of my 30 plus years here in Gainesville, about half of the time, early part of my life, we were focused on soil productivity type of work, and then the past 15 years or so, mostly on carbon sequestration and climate change. I don't have any expertise in the other activities, water quality enhancement, although my better half, Vimala, soil and water science, she has been involved in that, some of that work. And so I have been collaborating with her on that activity. Biodiversity conservation, I don't have any experience in that aspect, except to read some of the papers that are coming out of that. So there's a little thing about these different activities. The soil productivity work is always focused at the local level. If you look at the water quality, it's mostly at the landscape level. Then you are, stepping up laterally in the biodiversity and climate change mitigation. You are tackling them at a more regional and or global level. Okay, so with the leadership of Pedro Sanchez and Cheryl Palm and other scientists from at that time who were in Kenya, they are here, and so a lot of work has been done in the soil productivity areas. And the purpose, as I mentioned in the beginning itself, is not to go into any of the details, but there are several circumstantial evidences that support the hypothesis that trees can improve soils. And we don't want to, we don't have the time to, or even the need to go into any of those things. And after lots of deliberations and work and all that, I think the main mechanisms that contribute to soil fertility improvement in agroforestry can be summarized as benefiting from the nitrogen fixation ability of some trees, what we call nitrogen fixing trees, the biological nitrogen fixation, nutrient cycling related to tree biomass, and then nutrient uptake, to some extent, nutrient uptake from the deeper soil layers. There are also other tree-mediated benefits and services like improved soil physical conditions and soil erosion control, control of soil degradation, and all those things. So these are the main mechanisms. The summary of all this work that has gone into soil productivity issues of agroforestry, I think these are the main things that come out of those things. Biological nitrogen fixation, we don't want to go into any of the details here. We have the term fertilizer trees that to capitalize on the nitrogen fixation ability of some of the trees. There are several trees in the, I think they had a slide earlier. Okay, biological nitrogen fixation. There are certain trees, particularly in the tropics, that have the ability of nitrogen fixation. To my understanding, correct me if I'm wrong, there's only one genus, Robinia, that is not, it's a nitrogen fixer, but it's not a tropical species, Robinia pseudoacacia. All other nitrogen fixing trees and shrubs, they are tropical species. And there is a wide variety of them. Several of them are being used in farming system, crop production practices. People plant these nitrogen fixing trees like Gliricidia in this case, along with corn, maize, and they use the leaves from the trees. Either they add that as mulch to the soil to enhance the soil. These mulches decompose very rapidly because they have very high, relatively high nitrogen content and very low polyphenol content, and so they decompose rapidly and release the nitrogen to the growing crop. So these are the things that the underlying principles involved in that. So this is an activity that has been researched on quite a bit. Then the reclamation of degraded land, 5 million hectares of millet production area in West Africa is being replanted by that tree I showed you earlier, that miracle tree that has a special phenology, Phyderbia. So there are some such activities going on. Now, coming to my second half of my work here in Gainesville on climate change mitigation. Nobody wants to see this graph again because everybody has seen different versions of this one. The point I want to make is that climate change has been going on, and lots of activities are going on in climate change. And the our main input in climate change mitigation is the sequestration of carbon in biomass and in soil, and thereby address the climate change issue, mitigate the climate change impact. So carbon is stored, as you all know, above ground and below ground, and we believe that agroforestry systems have a higher potential than single species crop or pasture systems to sequester carbon because of their perceived ability for greater capture and utilization of growth resources. And this has been the underlying hypothesis that that we have been trying to investigate. Lots of estimates of carbon stored in soil. It's not a carbon sequestration rate. This is a carbon storage, tons of carbon per hectare. So lots of data are available. Some of them are not as authentic as others are, as it always happens. So our work here, we had conducted field studies on certain hypotheses in different parts of the world, like in the Dehesa system in Spain, the shaded perennial system in southern part of India, home gardens also in Kerala in India, parklands in Mali, West Africa, shaded cacao system in Bahia in Brazil, and the silvopasture in Minas Gerais in Brazil. So on all these different situations we have with the involvement of graduate students and visiting scientists and all that, we have undertaken a set of studies following some sort of a uniform methodology. And so I'm not talking from vacuum. I have a little bit of experience in doing some of these things. And as it always happens, we also have published some of this work in a number of journals and all that. There are, I'm trying to rush through because I know that time is catching up. There are some real misconceptions in the discussions on carbon sequestration in agroforestry systems. A lot of people, I have been the editor of the Agroforestry Systems Journal for a long time. A lot of people write up the results and saying, and they estimate biomass, they determine or estimate biomass, and they say, oh, half of that is carbon and that is carbon sequestered. No, that is rubbish. That is not sequestered carbon. That's biomass. So this is the type of thing, research papers that come out, you know. And then there are lots and lots of activities on estimating global areas, global estimates of carbon sequestration. And I would even say it's a craze, especially in climate change research. I submit that their applications to agroforestry are rather limited. Most of the available models are limited to, correct me if I'm wrong, they are limited to single species systems. They are not easily applicable to agroforestry systems with complex and uneven plant arrangements. So how realistic are they? So I have come to I have serious doubts. If are the carbon sequestration benefits of agroforestry being oversold? The way some people are promoting this, I question myself. Really, is it possible? So currently, for example, the atmospheric CO2 concentration is 400 parts per million, and 1 ppm of CO2 in the atmosphere is almost 8 billion tons, okay? And the goal is to reduce that ppm from 400 to by 65 ppm. That means about 500 billion tons of carbon has to be sequestered. Realistically, how much of this can be accomplished through tree planting activities, including agroforestry? But tree planting has become very trendy lately, and not lately, but for quite some time actually. Even in the recent World Economic Forum in Davos, a global initiative was announced to plant 1 trillion trees around. And guess what? Even President Trump was in support of that. That's something really interesting, isn't it? So there is lots of activities, a lot of emphasis being given to this sort of activities. And there is, what is the science behind it? A paper in Science in July, some of you may have seen that, says that planting 1 trillion trees could capture more than a third of all the greenhouse gases humans have released since the Industrial Revolution. Okay, and then what is the best way to implement this program? That is also being discussed. And another paper that appeared in PNAS just last week says the most effective way to protect the Amazon rainforest might be to leave it in the hands of its indigenous residents. Aha, now we are coming to census. Involve local people in whatever you are trying to do and mess up with in this business. That is, I think that's the message we can take home. So in spite of all these questions and almost all the development paradigms in existence today, like we name it, agroecology, agrosystem management, all whatever be the development bandwagon that we are dealing with, they all they have agroforestry is mentioned there prominently as one of the greatest things that people can accomplish in accomplishing their objective. That's why I said earlier that I don't know if agroforestry is being oversold. So to conclude my talk, I would say agroforestry has come of age in the past 40 plus years. And I think we have accomplished a little bit of transformation of the vague concept and traditional practices into a science-based land use discipline. And some of its roles have been clearly demonstrated in sustaining crop yields and diversifying farm production and realizing ecosystem services and ensuring environmental integrity. Thank you.